Okay, now we are going to discuss solving basic equations with logs. In a later section, we're going to get more into detail with this, but we're just going to introduce you to the most basic possible log equation to solve. Now, because log equations and exponentials are inverses, just like if I was trying to solve x squared is equal to 4, I would use the inverse of squared, which is the square root, to figure out what x is, to undo that squared. So if I have a log equation and I'm trying to find x that's in that log equation, I want to undo that log so that I can solve for x. So I'm going to use exponential functions. So I'm going to put any log equation that I have in exponential form so I can isolate that x. So in example A, this is my base, and this would be my exponent. So I would rewrite this as 6 to the third is equal to x. So my answer would be, when I take 6 to the third, 216. So x is 216. In example B, my base is 4, my exponent is -3, so I would have 4 to the -3 is equal to x. And then I would take 4 to the third, which is 64, and that negative tells me to flip it upside down. So my final answer would be 1 over 64. Now, in this example here, part C, I don't see my base. It's not listed, but because it's ln, I should know that my base is e. So my base is e, my exponent is 7, and so x is going to be e to the 7th. This is considered the exact answer. And then if I want to figure out what that is as a decimal value, I can put that in on my calculator and put in e to the 7th. I would get 1096.63. And this would be considered the approximate answer because it's a rounded decimal, versus e to the 7th would be the exact answer. Okay, and then the last problem, part D, my base is 10, even though it's not written in there, because it's log with nothing there, I know my base is 10. So I'm going to have 10 to the power of x is equal to 100 to the 8th. Now, this is a little bit more work in order to figure out what x is. I'm going to rewrite 100 in the same base as base 10. So 100 can be written as 10 squared. And when I raise a power to a power, I multiply. So 100 to the 8th is also equal to 10 to the 16th. So since I have 10 to the x is equal to 10 to the 16th, x has to be 16.